I've been getting back into GNU Screen, and I just wanted to show that there's a way of doing traditional Unix C system software development on Windows Windows services for Linux virtual containers that might interest some people, instead of having to go the whole MSVC code, Visual Studio Code route, which seems really heavy duty. So what I've got here is a few terminal installed PowerShell 7, and I've installed some terminal windows. I've started up some terminal windows. I pinned the icon to the taskbar, and so I start a terminal and I start Windows services for Linux in that terminal, and I've set up 3 there and 1 here. Now this one is running GNU Screen, and the control sequence to enter GNU Screen commands is Control A. So whatever application is running, like what's running at the moment is Vim under Ubuntu Linux on a WSL virtualization, and I can now type Control A and double quote to list my windows, and I've given each one of them a name. So one of them contains a bash shell, one of them contains the manual page for standard argument, variable argument list macros. I'm actually not using those, so I don't really need that, but the other contains VI running, editing this file flog.c, and I'm writing C code in that, and all these 3 are running under Screen in the same terminal window. They're all running in this terminal window, which leaves these 3 free to run anything else. I don't actually need them. I could compile in one of these, or I'm just going to close them, because originally I was going to set up one each. So now I've just got a single GNU terminal running Screen with all these sub-processes. If I switch to bash, I've now got the manual page for GNU Screen running. And these commands that you can type into GNU Screen, how do you type in these commands? Customization, I think these are what go in the .screen file. It's a huge package, Screen, but it presents itself as an absolutely minimal. You don't even know it's running until you press Control A, or until you edit your .screen file, .screenrc. Screenrc or .screen? The socket directory. So it's listening on a socket for commands. When Screen is invoked, it executes initialization commands from etc. screenrc, which is system-wide, and defaults that can be overridden in the following ways. For the global screenrc, the screen searches the sys-screenrc. The user-specific screenrc is searched in $screenrc. then home.screenrc. I haven't got any of those. I haven't needed to set them up so far. Commands. Customization can also be done online. To enter the command mode, type Control-A:. What I did have to do was run screen. I had to create. I'm going to type Control-A:C to create a new screen window. And now if I press Control-A:, we see that the new screen window here is called Bash as well. I'm going to change the name to this by typing Control-A, A, and it asks me for a new title. Oh. Control-A. Oh, no, I have to switch to it. Control-A. The new title is not going to be Bash, it's going to be I'll call it commands just to distinguish it from my shell window. Now if I type Control-A, I've got this commands window as well as my Bash window. So in the commands window, if I go back to the Control-A2, you don't have to look at the menu. You can just press Control-A and give the screen the virtual screen number, which is 0, 1, 2, 3, etc. in the list in that order in which they were Control-A-C'd to create them. So if I go back to the manual page, I've got things like CL-add usernames, add ACL, ACLs, access control list. Enable users to fully access the screen session. Usernames can be one user or comma-separated list of users. This command enables to attach to the screen session and performs the equivalent of ACL change. Oh, so on a multi-user system, you can actually allow other users to access your screen sessions. Wow. Well, that's a whole new world of stuff there. If there was a network of if I had a local area network or something, I could presumably link via TTLs. How do they? These users would be users on the same box. So if I go back to commands, Control-A4. If I go back to commands and type who, there's no one logged in. This is a quirk of virtualization on WSL. It's weird. It seems to provide virtual screens. It has got sudo TTYs for each process, but the users aren't considered logged in, because if you type who, you don't get any users. So init is the root process. There's a way of doing a tree output for PS, what's that? PS is Unix command for process status. To print a process tree, PS EG big H or AXJF. PS is old style, and it's traditionally from a long way back you could give it options without putting the minus sign on them. That's these guys here. PS AXJF. This is useful because it shows you the process tree. So we've got inits whose parents are more. So the only thing that's actually running here is process 40 with a parent process of 1, process 1 with a parent process of 0. So in Unix, I don't know what constitutes, but things like write, the Unix write command, which allows you to write text onto someone else's teletype, doesn't actually work on WSL because, again, there are no users logged in. Write would allow you to communicate onto TTYs. But we should, if we go back to that process tree, we should be able to see that screen is now sitting on top of 3 more. One of them is running PSAX, one of them is running the screen manual, one of them is running the VA start manual, and one of them is running VI. So in the absence of window names, this can actually tell you a little bit about what screen processes. Screen itself is using pseudo TTYs to talk to connect the processes with the keyboard. This is way more complicated than anything that Edgar Dijkstra contemplated. But that's kind of Unix all over. I wonder what Dijkstra thought of Unix. And the fact that he used an electric typewriter to write most of his stuff suggests that maybe he wasn't that enamored with it. Anyway, that's a 13-minute video, that's enough. I hope somebody enjoys this.